Alright, today we're going to be looking at section 1.4, which is talking about exponents and the order of operations. And really just the way in which you perform operations, there actually has to be a specific order to them. You can't just, there's probably, many of you maybe on Twitter or Facebook have seen those challenges where they're like, do this math problem, and it's got like division signs and multiplications and additions, and sure enough, like everybody in the comment section always puts like completely different answers. Today, this lesson will help you ace all of those ridiculous challenges. So you should be able to absolutely smoke all those challenges whenever you see them. So let's just go ahead and take a look through these notes and then go through just a few examples just like we did the last time. The first thing that we want to look at are exponents. So let's take a look. An exponent indicates how many times the base occurs in multiplication. So for example, if I have 3 to the 4th power, right, that's the way that we say it, 3 to the 4th power, or 3 to the 4th. That's the same thing as 3 multiplied by itself 4 times. So the exponent is indicating how many times you do multiplication, or how many multiplications of that base you do. So 3 is the base, 4 is the exponent. The left side of the equation above is called the factored form, and the right side is called the exponential form. There's a few more examples in the textbook. You can go ahead and take a look at them for reference. They're on page 34 and 35. So how do we deal with order of operations? So we just introduced exponents, and we'll do, again, like I said, a few examples here in just a few minutes. So the order of operations agreement is the way in which you perform operations. There is a correct order when you do adding and subtracting, multiplying and dividing, and applying exponents. So the first thing you do is you perform operations inside of grouping symbols. So those are brackets, parentheses like these guys. The brackets are squared off, and absolute value symbols. We'll talk a little bit about this further on. Right now you don't have to worry about them too much for this section. So then the first thing we do brackets and grouping symbols. The second thing we do is exponents. The third thing is multiplication and division from left to right, and the fourth is addition and subtraction from left to right. So here's an important note. Back when I was in grade school, I learned this really helpful mnemonic device, just a helpful way to remember the order of operation. And it was, please excuse my dear Aunt Sally. And if you don't like Aunt Sally, you can change excuse to execute if you want. I don't have an Aunt Sally, so I can say that. But if you do, then shame on you. You should not do that. Please excuse my dear Aunt Sally, right? PEMDAS. PEMDAS, P-E-M-D-A-S. So parentheses, exponent, multiplication and division, addition and subtraction. Okay, and you can see that expanded out here. So here's an example. Here is 3 to the 3/4 raised to the 2nd power times 2 to the 3rd times a -4. Okay, how do you go ahead and do all that? So I actually wrote out the whole process here, and I mean, again, this is just an example that really breaks it all down and shows you what you can do. So this is mostly just for your benefit. Again, if you want to see all these notes, they're all on Canvas in the home page. If you scroll all the way down to the bottom, they're all listed right there. So yeah, let's go ahead and take a look at a few examples here. Switch over to my whiteboard. And I'm betting it's going to turn off here at some point. So hopefully I can beat it. 12, question number 12. Let's take a look at 7 to the 4th power. So we're going to do a few exponents first, and then we're going to jump into some order of operations. Okay? So 7 to the 4th, this is the same thing as 7 times 7 times 7 times 7. So I do it 4 times. 1, 2, 3, 4. And if you can do it in your head, I'm just kidding. You probably can't. I can't do it in my head. 7 times 7 is 49. This would be 49, so it would be 49 times 49. Multiplying two-digit numbers is pretty tricky. I've already done this in a calculator, so you can do that if you'd like. This is the same thing as 2401. Okay, so that's the solution to that guy. Oh, real quick. So I want to make sure that you guys are all aware of this, because this is actually a really important distinguishing factor when you look at exponents. Okay, so question 14. This is a perfect one. Minus 4 to the third power. Okay. There is an important distinction between something that looks like this, minus 4 to the third, and this. These are not the same things, okay? So these are not equal. And the difference, if you notice, is that the brackets right here, the parentheses, mean that I'm taking this. So let's just expand it so you can see exactly what I mean. This is minus 4 times minus 4 times minus 4, okay? This is what that equals. It's the same thing. This, on the other hand, is something different. This is minus 4 times 4 times 4, okay? So the minus sign, if there's no bracket in place, then what you're doing is you're taking the number and raising it to the exponent, and then whatever you get, you make it negative. Okay? Over here, in this case, this actually works out to being, technically it's the same thing. But the reason why is because this is an odd exponent, and if it was even, it wouldn't be the same, because the negative signs would cancel each other out. So here I actually get negative 4 times negative 4 times negative 4. This is a negative, 64? Okay. It works out in this case where it actually is the same thing, but if I were to change it to say something like this, so I'm going to go ahead and change it real quick. If I changed it to negative 4 to the fourth power, this would not be the same as negative 4 to the fourth power. Okay? Again, the parentheses make a huge difference. They make a big difference, and I always suggest everybody to write them out. So this is negative 4 times 4 times 4 times 4. This over here is negative 4 times negative 4 times negative 4 times negative 4. Okay? So that is what this is. This is what that is. So again, when I go ahead and write these out, oh gosh, what's 64 times 4? Let's just go ahead and do that real quick. 64 times 4. You're probably already ahead of me. Arithmetic was never my strong suit. I always struggled with that. So, 6 times 4 is 12, 18, 24, 25, 256. Okay? So 256. So this right here is going to be 256. And now we count the negative signs. 1, 2, 3, 4. 4 negative signs. If you have an even number of negative signs, that means it's positive. And over here, notice how the negative sign is out in front. That means that I've got a negative 256. So look, these things are not the same. Okay? I'm telling you right now, I promise you this. I know for a fact that there's going to be a number of people who make this mistake. And it happens every single semester. And I really want to try to draw your attention to it early on, because it is super important. So make sure, if you see parentheses that are in front of or containing the negative sign, I should say, if the parentheses are containing the negative sign, that means that you have to bring the negative along when you multiply it all out. Okay? When you don't have the parentheses included or raised to the power of 4 in this case, then the negative comes out in front. Okay? So that's super important. It does really make a difference. Okay, let's go ahead and do one more. I want to do a fraction just so you can see how that works. So let's do minus 3 over 4. Okay, and we'll raise it to the third power. So remember what I did last time? You can bring the minus sign up in front to the third. And then now you actually have a fraction raised to an exponent, or raised to the third power. So how do you resolve that? Well, what you do is that 3, that third power, actually goes to both the numerator and the denominator. So what I have, if I were to write the whole thing out, I would have minus 3. Actually, let's do the let's separate it first before I do that. Minus 3 to the third power all over 4 to the third power. Okay? And now multiplying that all out, I would have minus 3 times minus 3 times minus 3, all divided by 4 times 4 times 4. Okay? So that means that, well, we just do the multiplication. There's 3 negative signs, which means it's going to be negative because it's odd. 3 times 3 times 3, so 3 times 3 is 9. 9 times 3 is 27. And then 4 times 4 times 4, we actually just did it, which was 64. And that is our final answer. There you go. All right, so that was actually question 20, in case you were curious. That was question 20. Let's go ahead and move along. Let's start doing some order of operations with just a few different operations all applying on one another. So, well, let's do, you know what, let's do multiplication. Yeah, check this out. Let's just do 32, okay? 3 over 4 to the second power times 2 to the third times a negative 4, okay? All right, so let's first take a look at the exponents, okay? Let's rewrite. I always encourage everybody to rewrite stuff out until you get really comfortable with it. So the 2 is going to go to both the numerator and denominator in a fraction, remember. So we've got 3 squared over 4 squared times 2 to the third times negative 4. There's no exponent on the 4, the negative 4, so that's good. And then now we can multiply it all out. 4 times 4 times 2 times 2 times 2 times a negative 4. Okay? Again, I really encourage you just to write it all out. If you can do it in your head, great. But really, early on in this class, I think it's really helpful just to get into the habit of writing everything down. Because if you make a mistake, you can always go back and kind of trace your steps to see where you made that mistake. All right, so let's go ahead and take a look at this. We'll just simplify each piece. So we'll do the fraction first, and then we'll do all of this stuff. So 3 times 3, that's going to be 9 over 16. And then we're going to multiply by 2, 4 times 2 is 8. 8 times a minus 4 is a minus 32. Okay? And now here's the thing. Because this is 32, you know how the last time I said when we have fractions and we're multiplying by another fraction, we just do across? So for multiplication, it just goes across. So when you have a whole number like this, or this in this case, this is an integer, what you do is this is the same thing as 9 over 16 times minus 32 over 1, right? 32 over 1 is the same as 32. So I'm not sure if I said this, but when you multiply anything times 1, you get itself, right? So if I do 50 times 1, I get 50. But if you divide anything by 1, you also get itself. So it works out in both ways. So dividing by 1 will produce itself, but this is nice because it allows us to multiply across the numerator and denominator. So here we have 9 times a minus 32, and that is going to be, in case you're curious, I did this ahead of time, so I just don't want to waste time. This is actually going to be a minus 288. 288. Minus 288. And then the denominator, 16 times 1, is just going to be 16. Okay? All right, so we can actually go even further. We can get this down to its simplest form. Let's just start dividing everything by 2 and seeing what we get. How's that sound? So this is minus, cutting that in half, you get a, I'm going to come all the way over here, minus 144 all over 8. That's the same. Now we can keep cutting it in half. Minus, 72 all over 4. We can keep going, cutting that in half. 36 all over 2. And we can keep cutting it in half. Because, again, I'm cutting it in half because you can actually do that with even numbers. So if you have evens on both the numerator and denominator, it just makes life a lot easier. So minus 36 over 2, that is going to be a minus 18. And that's what we have. That's our final answer. So yeah, there you go. Now, again, it's trivial to do a lot of this with a calculator, but to be honest with you, it gets handy. If you know how to do this all on paper, what happens is it's starting to reinforce a lot of just the way that you think. And so, yeah, you can probably do it in a device right now, but my encouragement is to really try to just do it on your own without the help of a device, because it just starts to build a lot of the patterns that you just of remembrance and things like that. So yeah, so let's keep going. Let's just do some order of operations now. So let's do the crazy Facebook challenge stuff that you always see. Sorry, Facebook is probably not your generation. It's my generation. I was in college when Facebook was invented, if that's any indication of how old I am. So, yeah. All right, so let's go ahead and take a look at this one. This is a, beginning. So what I encourage you to start doing is just write out PEMDAS. Please excuse my dear Aunt Sally, right off the bat. And then these guys are going to be grouped together. And then as we go through each piece, we just cross them off, okay? So let's go ahead and do that. There's no parentheses, so we can cross it off. There's an exponent, so that means 3. Rewrite everything out when we do the exponent portion. 2 raised to the second power is 2 times 2, which is 4. And then I've got a minus 3. So now that is done, okay? Now we go left to right and we do multiplication and division. So 3 times 4 is going to be 12. And we rewrite the minus 3. The multiplication and division is now done. And now we're left with 12 minus 3. And we do the addition and subtraction. So 12 minus 3 is going to be 9. And there it is. That's our final answer. Okay. So if you just follow this, the order of operations using this and crossing it off as you go through it, you're really just following the procedure. I want to go ahead and do a couple more complicated ones, and hopefully we can work through them. Okay. But again, following the procedure is really key in a lot of these problems. So minus 2 to the second power, there's that tricky one, remember, plus 4. And we've got some square brackets here. All right, 16 divided by 3 minus 5. All right, PEMDAS. So, parentheses. Let's take a look at items, operations inside of the grouping. excuse me, the grouping symbols. So we'll start off, we'll rewrite everything out. Don't go and bypass the order. So the first, you have to look at kind of, I guess the word I would use is like nested parentheses. So we've actually got parentheses inside of parentheses. So we're actually going to do this parentheses first. So for each time, you're actually doing an iteration of this within each parentheses. So 3 minus 5 is going to be a minus 2. Okay? 3 minus 5 is a minus 2. Now we have to do this parentheses. So again, rewrite everything out. Squared plus 4 times, and I'm going to make this a circle bracket, or just a half circle bracket, just because these square ones are complicated. 16 divided by a negative 2. Remember, we can do change it to a fraction if you want, like that, and it makes it a little bit easier to manage. So if I do that, and then I'm going to rewrite this first part out, plus 4. 16 divided by a negative 2 is going to be a negative 8. Right? How many times does negative 2 go into 16? That's pretty much what it's saying. It's negative 8 times. So that is ultimately what we get here. And again, you can remember, just divide everything by 2, and you get an 8, you get a 1 right there, and the negative sign is left over, which is where we get the negative 8. Okay? So now my parentheses are done. Now you're saying, wait, you have parentheses here. This is actually the same as multiplication. So there were operation when you're doing PEMDAS, you're dealing with operations inside parentheses for the P. Because there's no other operations in here, and I'm multiplying it by the 4, I just have to wait to do it until I get to this step. Okay? So now I do the minus 2 to the second power. Now remember, this is minus 2 times 2. Okay? I'm adding 4 times a minus 8. Okay, so I did the exponent. That's all done. And then now I do the multiplication and division. I'm on that step. So this is going to be minus 2 times 2 is a minus 4. I've got the 4 right here and the minus 8. So again, I'm going from left to right now. This is going to be a minus 32. And one of the things you can do, if you have a plus minus, you can just get rid of the plus sign right there and make it a minus. So that works too. Okay. So now my multiplication and division are all gone, and I'm left with addition and subtraction. So minus 4 minus 32 is a minus 36. And there's my final answer. So that one was a little bit more of a process, but you can kind of see my thought process. I like doing these more complicated ones because they involve really just a rigid kind of application of how you go through it. But even in the rigid application, you can still change the way that you think about it. So like I said, from thinking about it like this to thinking about it like this is a little bit easier, for me at least. If you think about it better doing it that way, that's perfectly fine. You can just leave it and then just remind yourself how many times, what is the answer when 16 is being divided by a negative 2. Right? So that's just, again, another example. I'm going to go ahead and do something that involves a fraction. Okay? And then I'll also do an absolute value. And I'll talk a little bit about absolute values here at some point, but I'll explain it. It's not really talked about in section 1.4, but they ask you to do a question with absolute values, so I'm just kind of like, what? Why did they do that? That seems a little suspicious there. 3 squared all over 8 minus 5 minus a negative 5. All right, so let's get our PEMDAS. Okay. And I underline, by the way, these guys, the M and the D and the A and the S, because they're grouped. They're in the same group, that you do it at the same time. All right, so let's do parentheses. There are, again, no parentheses because, again, there's no operations taking place inside of this. It's just a number. But actually there is, because take a look here. There's this fraction actually has a denominator, and you can secretly put parentheses around it. A denominator is like a separate part of a fraction, and so you can think of that as being like a grouped area or grouped location. I guess that's another way of thinking about it. So we'll do that. We'll do 24 divided by 3 squared over 8 minus 5, which is 3, minus a minus 5. Okay, so the parentheses are done. Let's move on to exponents. 24 divided by 3 squared is 9 all over 3, minus a minus 5. That's gone. Multiplication and division. First, before we do that, let's simplify this. It can actually be simplified. 9 divided by 3 is literally just 3. So 24 divided by 3 minus a minus 5. And that is a lot easier to deal with than this. Like I said, I like writing it as a fraction. You can do it however you want, but I prefer it this way. I just find it easier to deal with. So 3, how many times does 3 go into 24? That would be, what, 8 times? So 8 minus a minus 5. So that's the multiplication and division. And then we have addition and subtraction. So 8 minus a minus, this is the same as 8 plus 5, which is equal to 13. And that is our final answer. All right. Let us do one more. And here is what I want to show you about absolute value. It really is not, you're not going to be really doing a whole lot with absolute value until you get into intermediate algebra. But I want to, like, in terms of more complicated stuff, but the best thing I can do to explain absolute value is just make it positive. So you can think of it like a distance, right? Distance is always positive. It's never negative. You always have a positive distance no matter what. So from point A to point B, you don't say, oh, that's like negative 20 miles. Like, nobody says that. It's always, it's 20 miles away. Point A and point B is 20 miles away from each other. So that's the way I like thinking about absolute value. So whatever you have that makes it negative, you turn it into a positive. So 54 is 18 divided by absolute value 9 minus 2, and this is actually 2 cubed, plus a negative 3. So here we have our PEMDAS. So remember, the P is the grouping symbol, parentheses, and we have a grouping symbol here with our absolute value symbol. So let's write this out. Divided by absolute value, and inside that parentheses we actually have an exponent. So we kind of have to do its own little PEMDAS inside of the whole PEMDAS. I don't know if that makes sense, but just bear with me. So 9 minus 2 times 2 times 2, and there goes my camera. I knew it was going to turn off. It's got this weird timer on it. I'm not sure why, but hey. All right, there we go. So 9 minus 2 times 2 times 2. Again, remember there's no brackets surrounding the minus sign, including the minus sign raised to the exponent. That is outside, they're separate. So you get something that looks like this, plus or minus 3. All right, so now we have to do the multiplication and division. So 18 divided by, and again, I'm only looking at the stuff inside the grouping symbol first. So 9 minus 2 times 2 times 2 is 8. Plus a negative 3. Now I do the stuff again inside the grouping symbols. So the absolute value of a positive 1 plus a minus 3. Now, this is an absolute value of a positive number is just a positive number. So when you write it out, it's going to be 18 divided by 1 plus a minus 3. If this was, again, this is just for an example, if it was, say, negative 1, this would actually be the exact same thing. Because, again, I'm taking the absolute value, and what that means is you treat it like a distance. It's positive. So anything that's inside of an absolute value, just change it from negative to positive. So this is what we get, and now, again, I'll do the 18 over 1. Change it to a fraction, and then this is going to become a plus a minus 3. Okay, so that's done, that's done. That is done, right? Because this is going to just be 18, and I'm subtracting 3. So what do I get? 15? Here's my final answer. All done. Positive 15. All right, well, that's really it for this section. If anyone has any questions, let me know. I'd love to answer them as quickly as I can. And that is all. I hope you have a fantastic day.